Alright, so in order to explain CMSIS, I would like to visit this web page here, which is at developerarm.com at this location. Okay, the CMSIS stands for Cortex Microcontroller System Interface Standard. Okay, so at the end, the CMSIS is also a piece of code which is used for, okay, so which is explained here. The CMSIS enables consistent device support and simple software interfaces to the processor and its peripherals, simplifying software reuse, reducing the learning curve for microcontroller developers, and reducing the time to market for new devices. So in this diagram, the green boxes which you are seeing here, okay, is given from ARM. Those are the codes or layers, okay, software layers given by ARM, okay. So in this development scenario, okay, the very first section is your application code. So that I can match with my Eclipse project here, right? So in my Eclipse project, I have source directory, and here I have kept my application. So this corresponds to the application code, right? Great. So now what my application does, my application actually run on a microcontroller which is based on Cortex family of processor, right? Okay, so that means that is this layer. Okay, so this is my microcontroller layer which has ARM Cortex M core. Okay, that is the core of the processor, like the ALU, etc. Core peripherals, okay, like the ARM Cortex processor has lots of internal peripherals such as the SysTick timer, the NVIC engine, the debug interface, etc. Okay, and other peripherals means my microcontroller specific peripherals like timers, I2C, UART, etc. Okay, so and some other peripherals. So these are all the part of the hardware that is my microcontroller. Now your application is sitting here. Now the application wants to talk to your, let's say it wants to talk to NVIC. So what you do? So you can talk directly. Okay, it's possible. It is entirely possible that you can talk directly. Application can directly talk to NVIC by doing raw register access. Okay, so you can do that. But those kind of codes will not be portable when you change this processor. When you change this microcontroller, the address may be different, okay, or the register details may be different, okay, the bit fields may be different, okay. So that means the code you develop here cannot be reused when you change this microcontroller. And most of the time what happens is that the application developer will not be having any idea how to handle some of the peripherals of the processor. Okay, so in this case it is ARM Cortex M processor. Okay, he may not be knowing the register structure of the NVIC engine. He may not be knowing how to handle the SysTick engine, how to turn on the SysTick timer or turn off the SysTick timer. So how to enable the interrupt using NVIC registers, how to disable the interrupts using NVIC registers. So all these details application designer may not be knowing. So that doesn't stop him or her to develop any application for Cortex M processor based microcontrollers. Okay, what ARM says is that you need not to worry about those internal details. Okay, just use the CMSIS core APIs given from ARM. Okay, so what this CMSIS core layer does is it exposes various APIs to the application developer so that the application developer can make use of that and do whatever he wants to do with the microcontroller. Okay, so that's why it is called as CMSIS core, because it helps application developer to access some of the core peripherals of the Cortex M processor. Okay, now the question is why we should use CMSIS core in our project. So as I said, the number one point is you need not to know all the details of the Cortex M processor, okay? So that you just have to know some of the APIs provided by the CMSIS core and you can get started with programming. And second reason why we use CMSIS core is, look at this device HAL layer. This device HAL layer, as I said, is given by the silicon vendor, isn't it? So what silicon vendor they do is they develop their drivers using CMSIS core APIs, okay? So that's why in your project, if you don't give this layer, then while compiling your device HAL layer, your HAL layer will start throwing errors. That is, this is not found, that is not found, etc. So all the linking and compilation errors will come. So because the device HAL layer is designed by the vendor in such a way that they will not touch microcontroller peripherals or core peripherals directly. They touch it through the CMSIS core. So that's the reason you should give CMSIS core in between. So we are actually going through this path, okay? So in this path, don't worry about this CMSIS driver API that is not present in our project, and no middleware is present, okay? So but device HAL must be present and CMSIS core must be present, and at the end your hardware. So the flow comes something like this, okay? So that's the reason we should give CMSIS core, okay? Great.